Hey everybody, Pappy here. Today we're going to be looking at different types of circuits. Let's get started. What we're learning today in our lesson is about circuits and circuit conditions. This is a complete circuit, and what you'll notice is that the wiring, they're using A and B. It would most commonly be line and neutral. So A is a solid wire all the way through. This is the symbol for a lamp. So all the way through the lamp filament, out the other side, and back to neutral. It's a circuit or circle, and it's complete. Now, an incomplete circuit is just what it sounds like. It's the same as the one above, except in this case, there's a break in the circuit. So you start out from line, you go down here, and there's a break in the wire, and after that, it is complete. So obviously, this would be something that would be causing something not to work because the power can't get to it. In this case, a light bulb. So this is an incomplete circuit and has something that would need to be repaired. Now I want to show you that this is also an incomplete circuit, but it's because of a switch. So the switch is actually causing an incomplete circuit. It's not something that has to be repaired because it was built in order to manually open or close the circuit. So another term for an incomplete circuit is an open circuit. The switch is open. And here's another example of a closed circuit with a switch in it. Notice now the switch is in the closed position. Now, resistance in a circuit. In the example they give here, resistance is anything that impedes the flow of current. It resists the flow of current. And in this case, they've inserted, in place of a switch, a variable resistor. And what that does is it doesn't allow all of the current to flow through when it's in a very high level of resistance. And they're showing you here for a light bulb, when it's at the highest or maximum resistance, the light bulb is very dim. With medium resistance, it's a little bit brighter, half bright in this case. And when they change the variable resistor or variable switch to the lowest resistance, the light has full brightness. The main thing I want you to take away from here is simply that resistance will change the characteristics of the current and will affect whatever is trying to be operated, in this case, a lamp or a light bulb. So let's look at our training board for a minute and look at the flow of a complete circuit. And what we have wired up here is exactly the same as this circuit. It's a light bulb with no switch. So we have the power supply, line 1, coming in, connected here to one side of the light bulb. And then on the other side of the light bulb, it's connected to neutral. And the neutral side of the power supply. Very simple. So now let's move on. When you're diagnosing a problem with an electrical device, you need to be aware of how the circuits are built and the effect that it will have on the flow of electricity. There are 3 types of circuits mainly. There's a series circuit, a parallel circuit, and a series parallel circuit, which is just a combination of the two. So a series circuit is kind of just how it sounds. You have line coming in, and the light bulbs are connected in a series. Another way to do that with light bulbs is in parallel. Now, it's not 5 light bulbs, it's 3, but here, line is connected to each light bulb individually. Line, line. And on the neutral side, neutral is connected to each light bulb individually. Let's go back to compare that again. Again, this is 5 light bulbs, but it could be 3 and it's the same thing. Here, line is connected to the first light bulb, and then that first light bulb is just connected to the second light bulb, and then to the third light bulb, and then finally that is connected to neutral. Now, what's the difference there? Well, what happens is you get the combined resistance of all of these lights connected this way, so that they have to share the electricity, and they will be much dimmer than if this series were in parallel. In parallel, they each get their own individual amount of current and voltage, so that they will operate at full brightness from that connection. Whereas in series, since they are sharing the voltage and current, they will be dimmer. I'll show you an actual demonstration of that in a little mock-up we have here. Now, what I have is 3 light bulbs connected in series. We have it hooked to a 120 volt power supply here, which is off right now. And before I go into looking at this and testing this, I will put on my insulated gloves. So notice, like this circuit, we have line going to one side of one lamp. Here, line is red in this case, we have line going to one side of one lamp. And then that lamp is connected to the next lamp. So the connection here goes to the next lamp, and the connection here goes to the next lamp. And then the final lamp, and it doesn't matter whether it's 3 or 5, the number doesn't matter. The last lamp is the one that's connected back to neutral. And here we have that last lamp has a connection back to neutral. So we have neutral and we have line here. So let's turn this on and see what happens. Notice all of the light bulbs are lit. And I will put this together in parallel, and hopefully you'll be able to see the difference in the brightness. And while we're at it, let's check the voltage and the amperage. We have our meter. We turn it to volts AC. And we take the leads, and one goes to either side of the power. This is the power coming in, and then this is neutral. And we are reading 125 volts. So we have proper voltage here. These are 120 volt lamps. Now, how much amperage are they drawing? We'll turn it to amps AC, and we'll clamp around the wire. And you'll notice it reads, boy, just almost no amperage at all. It's pulling very, very little power. Okay, I'm going to turn that off, and I'm going to reconfigure this in parallel. So take a look at this and notice the difference, and see if you can see the difference in the light bulb brightness. This is the light bulb brightness with my garage lights turned off. And another thing about series circuits is that you'll see, because they depend on each other to continue the flow of electricity, if you have a bad filament in a light bulb, and that's what this wire inside the circle indicates, is the filament. That's a light bulb. And if you can see inside that light bulb, you see there's really just the two main wire connections coming in, and they go to a real fine wire that's looped around. And because it's so fine, it has a lot of resistance, and that's what makes it glow. But it is really just a wire. And in a series circuit, that's very important. You may have had Christmas tree lights that are affected by this, where one light would go out and the whole string goes out. So keep in mind, again, I'm going to turn the lights on, that each one of those lights, the power comes in, goes through the filament to the next light bulb, through the filament to the next light bulb, and then back to neutral. If I interrupt that circuit by unscrewing one light bulb, they all go out, because now, with that light bulb filament essentially broken or turned off, I have an open circuit right here, or an incomplete circuit. I screw the light back in, the circuit is complete, and all the lights go on. And it doesn't matter which one I unscrew, it's along this chain, and anywhere I break the chain, the power stops flowing. So any one of those, and that's actually one reason why you won't encounter a lot of this type of circuit, but you do need to be aware of it. So this is a parallel circuit again, and in your sheets you'll see there are different ways to wire parallel circuits, but the main idea is that on the load, which is light, heat, or motion, on the load, they are independently connected to line and to neutral. Neutral to one side and line to the other side. Parallel circuits are by far the most common type of circuit that you'll see in household, residential, commercial wiring, parallel circuits. So I've rewired our little test lamps here to be wired in parallel. And remember, with parallel, neutral and line are connected independently to each of the loads. The loads in this case are little lamps. So line is connected here, line connected here, line is connected here. Neutral is also connected to each lamp independently. What that means is that, for, say, take the first lamp, it will operate independent of the others because it has neutral and it has line. And the same with these other two lamps. Each one could operate independently, say, if the light bulb is out, and that's one of the advantages of a parallel circuit. But remember the brightness factor. I'm going to turn the garage lights up so you can see. So here we go. You may have to go back and look at the slide on the early one, but it's quite obvious, if you remember, that these are quite a bit brighter. And now I'll turn the garage lights back on so we can continue. See what we have going on here compared to the series circuit. I'm going to set the meter for volts AC, VAC. And remember, we pretty much ignore anything beyond the decimal. It's registering some minor voltage from the air, I guess. So I'm going to put my leads across here. And we're getting 123 volts. So essentially 120 volts. So we have that voltage. And what about amperage? We turn it to amps AC, which is the clamp feature on the meter. We put it around one of the wires. And notice, remember the series lamps had almost no amperage. Very little power was being drawn, which correlates with them not being very bright. But in this case, we have a tenth of an amp, at least 10 times more power is being drawn than the lights were when they were wired in series. So just from that, you might say that, well, series is a way to save on electricity, to conserve electricity. And I don't know in a way that that's used, but that would certainly be something that could be designed into many things. Now, again, with our voltmeter, I want you to see the voltage across each of the lamps, 124, 124, 124. So it's the same voltage going to each lamp. What makes those lamps brighter is that they are able to use the entire 120 volts to power each one individually. In the series circuit, the reason that they were dim was that they had to share the 120 volts because they had to use a little bit of it. Let's go back to that series circuit diagram. So each lamp uses a little bit of the power and then passes it on, uses it and passes it on. So here's a question for you. Would 5 lights in series be dimmer than 3 lights in series? Think about that one. And finally, there's the series parallel circuit, which is a combination of the two types of circuits. Here you have two light bulbs in series, and then you have 3 light bulbs in parallel. So in series, they're daisy-chained one to the next. And in parallel, remember, we need line 1 and neutral connected independently to each lamp. Now you can see the independent wire to each lamp in the parallel portion of the drawing. And you can see individually each lamp is wired on the line side. But look where line comes from. It's going first. It's using these lamp filaments to complete the circuit. That's line. So lamps can be used to carry voltage to another device when used in series. If you have any questions about the things that we discussed in the video, you can leave the comments at Pappy's Secrets YouTube or email your teacher. Thanks again.